Freefall Acceleration by Asha, Julia, Samarani, Tyler, and Fatma. The purpose of our experiment. The purpose of the freefall experiment on different kinds of balls is to determine whether or not shape, size, and mass of the balls have an effect on their acceleration and velocity rates. Additionally, after the experiment, results will be compared. This includes each ball's velocity versus time graphs, free body diagrams, flight time calculations, and percent errors. For the precise statement, the significant physics concepts used in this experiment include freefall and drag force. Freefall is any motion of a body where gravity is the only force acting upon it. Freefall can be expressed by Newton's second law of motion, F equals mxa. Drag force, which is also known as air resistance, acts opposite to the relative motion of an object and moves with respect to the surrounding fluid. Both freefall and air resistance can have significant effects on an object's velocity and acceleration. Air resistance decreases the rate of acceleration of an object as it goes against the force of gravity. Eventually, the falling object's thermal velocity will be reached as it will no longer accelerate, zero acceleration, due to air resistance. This is a video that shows how we perform the experiment with a balloon. The balloon y velocity versus time graph. For the balloon VT graph, there is an acceleration of negative 0.0606 m over s squared and a velocity of negative 1.322 m over s. For the balloon, there are a great diversion in velocity values, which can be seen by the dots on the graph indicating a slow acceleration. This video shows how we perform the experiment with a tennis ball. The tennis ball y velocity versus time graph. For the tennis ball VT graph, there is an acceleration of negative 9.422 m over s squared reflected in the velocity time graph. We see the slope of the VT graph is very straight and there is not much deflection from the acceleration, which shows a constant air and drag gravitational pull. This video shows how we perform the experiment with a ping pong ball. Ping pong ball y velocity versus time graph. For the ping pong ball VT graph, there is an acceleration of negative 9.403 m over s squared, similar to the tennis ball velocity time graph. We see that the slope of the VT graph is very straight, and there is not much deflection from the acceleration, which shows a constant air and drag gravitational pull that is only slightly less than that of the tennis ball. This is flight time calculations. For the flight time calculations, we used equations for both the motion with constant acceleration for the ping pong ball and tennis ball, and also for motion with constant velocity for the balloon. This is the flight time results. The flight time calculation suggests that as the balloon is not hitting the ground at the time of free fall, there is a constant velocity achieved by it, while ping pong and tennis balls are bounced back from the earth during free fall, leading to constant acceleration. This is the percent error. The percentage errors are derived from the diversion of the slope line of the VT graphs. For the tennis and ping pong ball, the error is less than 5%, is less than 10%, which is under acceptable limits. As for the balloon, the diversion is high, so there is a huge error of 28.93% in the calculation. This is because air drag plays a great role in free fall motion, and it highly depends on shape, size, and mass of an object. The force diagrams on Considering the force diagrams, we can say that due to the greater mass of the ping pong ball and tennis ball, the downward force experienced by them was greater than that of the balloon. Also, the greater mass requires more force to lift off, and therefore the upward force is less in magnitude in the force diagram. In conclusion, the balloon had a zero constant velocity while the other two moved with constant acceleration. Any object that is being acted upon only by the force of gravity has a free fall value of 9.8 m/s². This acceleration is experienced by all objects on Earth, regardless of mass. Air resistance can affect an object's acceleration, but force being applied by gravity remains constant. In this case, gravity pulls the air inside a balloon down, while the air wants to stay due to inertia. As a result, the balloon is forced to drag the air down with it due to air resistance. The less an object weighs, the more air resistance there is, causing it to fall down at a slower rate. Thank you for watching.